In this problem here, again, we have a quantity squared equaling a number. So let's square root each side. So we'll get the square root of this quantity. 3k plus 4 squared equals square root of 64. The left side, square root of the square, we know is going to give us the absolute value of 3k plus 4 equals 8. Let's take those absolute value signs off. So this is where we get plus or minus. We'll get 3k plus 4 equals plus or minus 8, which is really this. Now, oh, you know what? Let's do this. Let's subtract 4 and divide by 3. So here's what we're going to get. We're going to get 3k equals negative 4 plus or minus 8. Then we're going to divide by 3. K is equal to negative 4 plus or minus 8 over 3. And what this really looks like is this. If I stretch it out, I'll get negative 4 minus 8 over 3 and negative 4 plus 8 over 3. So this will give us k is equal to negative 12 over 3, and negative 4 plus 8 is 4 over 3. But negative 12 over 3 I can rewrite as negative 4 and 4/3. And then, of course, we could write this in set notation if we wanted to. So negative 4, you know what, let's write that negative 4 so it's readable. Negative 4 and positive 4 over 3. There's our solution. In 43, well, again, we've got a quantity squared equaling a number, so let's take square root. So we'll get the square root of that 8x minus 5 squared equals square root of 25, from which we will get the absolute value of 8x minus 5 equaling 5. Now when I remove the absolute values is when I get the plus or minus. So let's do this. Let's add 5. So I'll get 5 plus or minus 5. Divide the whole thing by 8. Get x equals 5 plus or minus 5 over 8, which is really, when we stretch it out, 5 minus 5 over 8 and 5 plus 5 over 8. So this will give us 0 over 8 and 10 over 8. So we'll get 0, and if we reduce, 2 divides each of these. How about 5 over 4? And if we write it in set notation again, we'll get 0 and 5/4. Let's do what we've been doing. Let's take square roots of each side. So we'll get the square root of the quantity 6 minus 5x squared equals square root of 70, right? Which is indicating what we're going to do. Now on the left side, square root of the square, we'll get the absolute value of 6 minus 5x. Square root of 70, I don't think there's any way to break that down into two numbers, one of which we know the square root. So I'm going to leave it square root of 70. Now let's take off the absolute value. 6 minus 5x, this is when we get plus or minus, not before. And now what I'm going to do is I'm going to subtract 6, right? I'm going to subtract 6. So we are going to get negative 5x equals negative 6 plus or minus square root of 70. And then I'm going to divide by negative 5. So now it looks like this. X equals negative 6 plus or minus square root of 20 all over negative 5. You know, but we just don't like negatives in denominator, so I'm going to bring this negative up. And just a quick little piece of information here. If you have a fraction with negatives, you can put the negative on the top, you can put it on the bottom, or you can put it out in front. They're all the same. I think the best one is this one right here. This is probably the worst. So I'm going to put the negative on the top. Now that's going to look like this. So it will be x equals negative, that whole top, negative 6, plus or minus square root of 20, all over 5. And then when I bring that negative sign in, I'm going to get this. X equals 6. Now negative times positive is negative. Negative times negative, right over here. Negative times positive is negative. Negative times negative is positive. So this is still plus or minus square root of, I don't know why I'm writing 20. That's supposed to be a 70 back here. Why didn't somebody say something? 70 all over 5, and I think we're stuck with that, right? We can't do anything more with that. So here's what we're going to get. 6 minus square root of 70 all over 5, and 6 plus square root of 70 all over 5. Okay, now in this 65, you can see we have something squared equaling a negative. So you know we're going to get imaginaries out of this. So let's start it. So let's square root each side. Square root of x squared, square root of negative 8. On the left side, we'll get absolute value of x equals. Now take the I out. 8. This will give us x equals, now we get plus or minus. Now, square root of 8. 4 times 2. Square root of 4 is 2. I'm going to write this as 2i square root of 2. And that's it. We're done. So I'll write it in set notation. It's going to be negative 2i square root of 2 and positive 2i square root of 2. And now up here in number 67, again we've got something squared equaling a negative. So we expect imaginaries here. Let's take square root. So we'll get the square root of r minus 4 squared equals square root negative 3. On the left side, we get the absolute value of r minus 4 equals, now I can take an I out, and that square root of 3, can't simplify that anymore. So now, let's remove the absolute value. We'll get r minus 4 equals plus or minus I square root of 3, right? When you remove the absolute value, this is when you get plus or minus. And now, I'll just add that 4, so I'll get r equals 4 plus or minus I square root of 3. And that's in the right form, right? It's in this form, a plus bi. So if I write it in solution set notation, we'll get 4 minus I square root of 3, 4 plus I square root of 3. There's our two solutions.